Electrolytics works in both molten and aqueous solution. In the previous video I also talked about how it works in a molten solution. So how does it work in an aqueous solution? So when I say aqueous solution, I actually mean that when some substance is poured into a liquid solution, that is what an aqueous solution of that substance means. So we all know that water is a covalent compound, so it has no charge. Now let's look at the structure formula of a water molecule. So there are two hydrogens and an oxygen. These are two poles. Okay. We need to look at the term electronegativity first. Electronegativity. What this term means is that the force of attraction felt by any of these atoms while forming a bond with other is called electronegativity. Now, oxygen is more electronegative than hydrogen, and since it's more electronegative, the electrons of its own, it pushes them towards itself a bit, and so these two poles becomes partially negatively charged, and comparatively these two poles becomes partially positively charged, so it does behave like an ion. And when some ionic substance, like let's say sodium chloride, we poured it into water, since it behaves like an ion, it separates this compound or substance actually and makes them ionized. They becomes ionized. Now let's see how the electrolysis works of sodium chloride in an aqueous solution. So first, we need to look at this. This is just a reactivity series. No, this is the reactivity series of cation, and this is for the anions. For cations, if you go downwards of this reactivity series, it tends to accept electrons. It tends more to accept electrons. So let's say if you take lithium and let's say gold will go at first to gain the electron than lithium, because it is placed downwards, the lithium. And for anions, if you go downwards, it tends to donate electrons. Let's say if you take chlorine and hydroxide will go first to donate the electrons. Now let's look at this cell. So it happened, we poured sodium chloride in water and they become ionized, sodium ion and chlorine ion. So what do you think will happen here? Since let's see what our cations are, sodium and hydrogen. So hydrogen is below sodium, so it will go first. So for cations, and this is the cathode, it attracts the cation and is negatively charged. So hydrogen will go first at the cathode, it will receive electron and leave the cell as hydrogen gas. And for the case of anions in this cell, anions are hydroxide and chlorine. So notice here that hydroxide is below chlorine, so hydroxide should go first to the anode and donate electrons. But in this case, actually chlorine goes to the anode. But why? It wasn't supposed to. Actually, other than the reactivity series, there is another more important concept, which is molarity. The substance which has more molarity or density tends to go first to make the reaction. The molarity of chlorine is 0.1 molar. It's 0.1 molar in a sodium chloride solution at room temperature, and the molarity of hydroxide is 10 to the power -7 molar in a typical water solution. So notice that chlorine is more molar than hydroxide. It is 10 to the power 6th more molar than hydroxide. That is why chlorine goes first to the anode and donates the electron. So let's see what reactions take place here. First, let's say the reaction of hydrogen. Hydrogen will go to the cathode and it will gain electron and become a hydrogen gas too. And what happens in our chlorine? So chlorine will donate electron to the anode and becomes chlorine gas, and it also leaves, just like the hydrogen gas, it leaves the cell as chlorine gas. So notice that there are two remaining compounds, ions, sodium and hydroxide. These two are remaining in the cell. So these two will form a bond between themselves and becomes remains, let me wrap this up, sodium hydroxide. That is what happens in a concentrated solution, or the aqueous solution of sodium chloride. This solution is also famous as the brine solution. See you in the next video.